fange jetzt an. Okay, so welcome back from the coffee break. We'll have now a session on networking intelligence. And I mean, in the spirit of this conference, we have not only academic, but also industrial speakers here. And this is a section entirely with industrial people. And we will start with Ewa Dürr. She is head of production management, production engineering for cloud artificial intelligence at Google. And she will talk today about empowering enterprises to transform their business with artificial intelligence. So we are so happy to have you from Google here and hear how AI is going to transform, hopefully also maybe related to some real action in the real world. That's what we roboticists are trying to push, how it's going to transform our society. So please welcome Ewa Dürr.
1, 2, 3, 1, 2, 3, you can hear me. Perfect. Good morning, everyone. Thank you for inviting me. As mentioned, my name is Ewa Dürr, and I lead product management for Google's cloud artificial intelligence organization in California. So I flew from the US, and I'm excited to be here to learn from German engineering of how we can collaborate together to bring AI to enterprises. Just to put the things into the perspective, I represent more practitioners organization within Google. So product management team typically works on bringing the AI to solve real business problems. In that context, I work a lot with engineering organizations. Within Google, you probably have heard of DeepMind, Brain, so I work with those organizations to bring really the best of Google to the industry. And my team really, harnessing the power of AI is what we do every day. Before I start on empowering enterprises to transform their business with AI, just a raise of hands. How many of you piloted AI technology within your enterprises? About 1/3. How many of you really use this in production at scale? Probably the half of that. And this is something that we found out as well. To bring AI into production is really difficult. This is just a survey from Gartner. About 53% of the projects within an AI space come from pilot to production. And this is a problem. Even though this technology has huge power, we are still at the beginning of the journey. And why is that? There are a couple of areas that we within Google identified, and we are trying to transform that and change that. The first one is data. This is simple, right? We always know that we need data to train any machine learning model. But what does this mean in more detail? In Silicon Valley, we typically say the C's. The data has to be correct, so no biases. Is it garbage in, garbage out? The data has to be current. And current doesn't mean only I have data today to train the model. I have to actually have the data as well tomorrow and in a couple of months. Because you retrain the model and you make it better and better over time. To make it really scalable, you have to have that data as well in a year. So assuring that you will have data over time to use the AI in production is a huge issue. And I don't have to mention the last C, which is compliant. So regulatory aspects, privacy aspects, and so on and so forth. The second challenge that we see is people. You probably try to recruit people. We within Google as well, in my organization, talent is really scarce. Even though TUM here as well and a lot of organizations are changing their curriculum, people is really a scarce resource. The third piece is integration. We've just discussed with Dominic all of the standards, even in the manufacturing space. This is tremendous, to bring things between cloud to edge to hardware. All those standards, there's so multitude. This is a huge issue to make sure that you can really bring that technology into the production. And last but not least, the ethical standards. I will double down on that in my presentation, how we are tackling that problem within Google. So just to start, how you can think about using AI within your organization. This is a very simple process. I took this example just to make the point. So in the PO process, purchase order process, you issue the PO, receive the invoice, capture the invoice data, manage the invoice, and so on and so forth until the payment. The AI can be used in this process in multiple ways. But let's, for the purpose of this simplistic exercise, we say that we want to capture the invoice data using an AI model, and we want to input that data into the system, into the procurement system. So think about how can you use AI in that system, in that simple example. There are 3 ways to do it. You can build your model yourself, so you can train the model to capture the invoice data and to input that into the system. You can buy the model because somebody, including Google, we've trained the model for capturing the invoice data. Or you can actually, not even knowing that you are using AI, buy the end-to-end system and use AI within that system. And the service provider that you are using for that is using AI within that. And I have seen, I actually haven't worked with any organization that decides for one or the other, but is using a portfolio of those strategies, depending on the use case that they are talking about. However, the decision that you will need to take is which use case and which strategy you have to use. So on the left-hand side of the spectrum, you can build your models yourself. You can have the people, the machine learning specialists, experts, data scientist team, and build everything from scratch. The good news, you can do it really in a very customized way, particular to solve your particular problem. The bad news is that you control the whole workflow, and there is a lot of work. So you have to have the talent, you have to have the data, you have to manage the ethical standards, you have to manage the regulatory aspects, and so on and so forth. On the other end of the spectrum, and that's the 4th point here, just to show the spectrum of possibilities that you would have, is practically buy a SaaS solution. All the providers would take care of all the aspects that we've mentioned here: talent, data, workflow integration, and ethical and regulatory aspects. So you can buy that, and within that, AI is embedded by default. And within Google, we try to empower enterprises to do all of the above, because as I mentioned before, I haven't seen any of our organizations that we have partnered with that does only one of those strategies. So on the lower end of the spectrum, you can actually take leverage of what we call AI development platform. So we call it Vertex AI. It's an unified development and deployment platform for AI that I will double down on that a bit later on in more details. The other aspect, you can actually purchase a relatively generic horizontal solutions based on conversational AI, NLPs, video AI, and so on and so forth. And last but not least, you can purchase as well or use any of the services of Google or any other service provider that tackle a particular industry problem that you are interested in in manufacturing, industrials, robotics, and so on and so forth. And I will give you examples of that as well. So this is just a spectrum of this Vertex AI platform or any other AI platform tool or platform as a service that you can use. That includes the whole workflow that allows you to customize your AI model to your specific and particular use case, from experimenting, through training, through deployment, through selection of the AI model, as there are typically multiple that you will be looking into. Up to the AutoML. Who has heard about the AutoML? Well, good news that people have heard about that. This is actually pretty famous because, and pretty useful. These are AI models that we have developed, and you can just ingest your data, and without really a lot of work, you can train a pretty robust model that solves your business problem. These are just examples of how this has been used by ASML in training their visual inspection model. On the horizontal side, so more on the generic side of this AI models, are the document understanding or the conversation AI capabilities that many of the providers, including Google, provides, and that's how we try to empower organizations to bring that AI technology into solving the business use cases. This is just a document understanding workflow, reading that document, understanding, and making it useful by inputting the data into the system. But the example I wanted to bring is rather something that is very close to our hearts and is very easy to understand, are the vaccination cards. So you can practically, if you go to the airport and you have to input your vaccination card status so that you can onboard the plane, this is all using AI. A lot of companies, flight operators, or even states in the US, as I was flying to Hawaii, they just trained the model for vaccination card so that the tourists can come and get their vaccination cards verified within the seconds, rather than doing that by the human being. So simple examples like that give you a flair of where this technology is heading and how useful and how easy it can be for some of the either governmental institutions or companies to use. This is just yet another example. And last but not least, more on the manufacturing side, I wanted to bring an example how this technology has been in the research area for many, many years, but really to achieve scale, and I'm coming from the practitioner side, I think all of you have heard about some way of using AI to mentor quality management, visual inspection, and so on and so forth. But there were a lot of challenges that we've encountered with the companies that we partnered with to really use it at scale. It was blocked at the research side. It was somewhere in the AI factory, but wasn't reaching really the scale at the global level. And why was that? The first one was the costs, right? So the business case. A lot of the data that you needed, the labeling that you needed, the images that you needed, and you didn't even need it once because your product portfolio is changing all the time. You needed that every day or every month or every couple of weeks. And that was a problem because labeling of that data was a problem. The second problem that we've heard was accuracy. 70% from the AI model of accuracy, this is just not good enough. You are all probably working with SLA, so 5 nines, 100% precision and recall, and so on and so forth. So that was a problem, that those solutions weren't reaching the SLAs that you had with the rule-based systems. So we tackled that within Google and took ourselves the challenge to really solve that problem for the manufacturing space. And we innovated in a couple of areas, and this is probably reflecting from left to right the degree of innovation that we tried to bring to that space. The first one is practically a very simple UI. So how can you very, very easily label, crop the data and the images that we are making? The second aspect is what we call, and some of you might know, active learning. So active learning, what it allowed you to practically, the system selects the images that should go into the training of the model and into labeling. And the last piece, which is the most innovative, and this is based on the Google's brain and DeepMind research that we've incorporated into that solution, is unsupervised learning. So visual inspection is now a mixture of supervised and unsupervised learning, allowing to really select very, very few images to train a very highly precise and accurate model with high precision and recall and F1 score. So that's really innovative. We have seen, and those who are a little bit into machine learning, we've trained models that are 100% accurate with only 10 images. This has been unprecedented. We took it as well from the, at least since I'm a practitioner, we took it as well from the use case perspective. I think on the left-hand side, you see anomaly detection. Anomaly detection is something that has been within manufacturing space as well for ages. This is practically answering the question, is the component or the product that you have on your manufacturing plant, does it have a defect, yes or no? But then let's take it a bit further, right? Let's ask a different question. If it's defected, then where, right? And if you are having, let's say, an electronic device or a semiconductor wafer, or a door car, sometimes it's very difficult for a human being to precisely say where is that defected, right? So cosmetic inspection, we took it a bit further and said, where is that product, component, ingredient, you name it, whatever you have in your manufacturing plant, where is that defected, and then highlighting that spot, and you can see that here in those blue or yellow areas, right? And the last piece we took is, if I'm expecting a product, what are the missing parts, right? So that's another use case that we took into the consideration to bring visual inspection really and the quality management to the other area of expertise. And where did we use it? Within Google, we typically don't bring anything to the market that we haven't tested ourselves. So this is just the first area that we incorporated that into inspecting our own hardware. And before we brought it to the market, so we call it within Google dog fooding, so eat your own dog food, and this is where we are eating that, right? So we brought visual inspection as well to our own manufacturing plant, but as well a lot of companies in the meantime use those solutions like Renault in inspecting the welding defects, or Foxconn achieved actually with very, very few images the precision and recall of 100% using that for assembly inspection. And the last piece I want to finish with is actually the one that is the closest to where I think we all have to be and we all have to think about, is the ethics and the responsibility. As I mentioned, AI is super powerful, but it comes with super powerful responsibility that we all need to take into account. So within Google, we always say responsible AI equals successful AI. Otherwise, this will not break through. And we have seen, and we conducted a research together with Economist Intelligence Unit that said responsible AI and ethics in AI is increasingly important, not only from the regulatory point of view, but as well from the ethical point of view. So 91% said that they incorporated those aspects into their RFP processes. 77% just declined any proposals from providers that didn't comply with ethical design and ethical standards, and so on. So in a nutshell, this is a super important topic and will become more and more important in the future. So how practically, and this is just one of the areas and one of the point of views that you should look at. Your organizations will tackle those problems and those areas very differently. This is how we decided to tackle those issues. The first one is, as I design my product and my team designs the product, the first aspect is we go through a review within Google. So within Google, there is a responsible AI team that does nothing else than every single day think about how my products can be misused before they reach any market or any client. So this is super important because there are a bunch of legal people, engineering people, product people that really challenge me and my team. And within those reviews, they ask very tough questions, how this technology can be misused and how can I implement any checks and balances so that once this product goes to the market, it's not really harmful or damaging. The second area is we develop a lot of features within our products that I will give you an example of those, how we incorporate those into our products. Then we empower our partners and customers to really use AI responsibly through giving a bunch of trainings, through incorporating and giving tools into integrating AI responsibly. And last but not least, super important, we work with the regulators to really learn from them how to incorporate and how to enhance our processes internally to be really regulatory compliant. I won't go into that. I would just want to give two examples of very, very practical features that we implemented to bring really AI in a responsible manner. So there is always an aspect of, there is this black box of a model that goes with the input and outputs something, right? So the regulators, for good reasons, asked, so what's happening in there, right? And this is where we implemented explainable AI, which practically gives you an answer on which are the features that contribute to the output of the model. So this is a step in, it's not the full explanation and bringing transparency to the black box, but it's a step in the right direction. And the second area that we implemented are the model cards. The model cards are something that we innovated and that explain the model, which are the models, which are the features are being used. And it was inspired practically by the nutrition labels that you know from the drinks or foods that allow you to take the decision of whether you use the product or buy or consume the product, right? How much sugar it has, how much fat it has, and so on. You can decide. So the model cards give you that opportunity to give you that information about the model, right? So you can still decide to use it, even though not all the aspects are correct. But still, it gives you that information. So in a nutshell, I just want to repeat that this aspect is hugely important for all of us. And if there is nothing else you would take from these presentations, and as I'm finishing, is that this is a huge responsibility. So take it seriously. Thank you very much.
Thank you very much. Thank you, Ewa. We have time for maybe 1 or 2 quick questions. Please just stay here for, let's see, Wolfram.
Yeah, thank you. This is amazing and very, very interesting. What I'm wondering is the example that you gave are mostly big companies, right? In Germany, you have this particular situation that we also have a lot of SMEs. And what is your take on how to empower also like smaller companies in order to use these tools? I mean, setting up entire teams is going to be difficult for them. So maybe you're getting your opinion on that.
Perfect, and excellent questions, and we actually think very actively about that question, right? And I think within our portfolio, we at least try to give some opportunities for SMEs as well to use AI. And this AutoML, some of you have heard about it. This is really super simple, right? And we have the whole team that focuses on small and medium enterprises and really brings those products to their attention that they can use without having big data science and ML experts team. And within Vertex AI, there are a bunch of other tools that are helpful that the companies can use. On the other end of the spectrum, we as well partner with a lot of communities or organizations that bring the power of AI into small and medium enterprises. One example that I am very much in favor here in Munich in particular is applied AI. I'm not sure whether some of the people have heard about that community space. They really bring the industry, the startup ecosystem, and the university expertise and the research to empower even small and medium organizations to use AI and any of the software solutions and empower their teams to use it.
Maybe one more short question, short answer. There were several hands. Who was that? Okay, no more question. Then let's stop here. Thank you very much again, Ewa.
I will be staying here, so happy to answer any questions later.
Maybe lunchtime is a good time
Perfect. Thank you.
Continue discussion. Okay, so then let's go ahead with the next talk, which is Dominik Metzger. He's a head of product management, manufacturing, and industrial IoT at SAP. And he will talk about the network-aware factory and its impact of business networks for intelligent factories. In his abstract, he talks about that this is one of the new megatrends which he would like to present in this session, network-aware factory. So let's hear how SAP thinks to enter production. I mean, we know them, of course, as being a world leader in administrative aspects, that they go more and more into production. And of course, they then also have interfaces to manufacturing, production, and robotics. So welcome, Dominik Metzger.
Okay, wonderful. So first of all, I'm delighted to be here today and present to so much innovation spirit in the room. I think it was already perfectly introduced. The topic I want to talk about is the network factory. So what I will be doing, the goal of my presentation will be to take all of you who are practitioners, who are extremely experienced in robotics and, let me call it, the shop floor automation reality, and take you with me on a bit of a macro level. Right? So the goal of my presentation is to take a view, almost like a helicopter view, out of the factory and how factories are impacted by global supply chains. My name is Dominik Metzger. I'm local here to Munich, so super excited to be here and representing Thomas Saueressig. He is our executive board member for engineering and unfortunately not able to make it today. So I'm even more excited to therefore take you on the journey with me. And I really want to start with a bit, as I said, of a macro view. And I'm sure all of you here in this room have followed, even long before the pandemic started, the vulnerabilities of global supply chains. And this is a super, super simple snapshot of supply chains. Any manufacturing company, even SMEs or especially SMEs, are working in highly interdependent global supply chains where the parts you buy, where you source your products from, and how you manage logistics, your distribution center, your warehouses, how you interact with logistics providers, trucking companies, shipping lines, but then also, most importantly, how you distribute it to your customers is a global or globally highly complex network. Now, what for us, and we talked about SAP's focus, let's say, on back-end processes, what we believe is a key to resolving some of these, let's say, challenges that global supply chains see is to really build what we call a digital twin, not only of assets or equipment, robotics, for example, but a digital twin of the entire end-to-end supply chain. So what you see here is a super, super simplified supply chain, right? We only have one tier. A tier means I only have one level of suppliers, right? In the center here is my headquarters where I'm producing with factories, with warehouses, and on the far left I have my customer and distribution channels. Why is this so simple? Because every single supplier here on the left has their sub-suppliers, tier 2, tier 3 suppliers, and irregardless if we look in the high-tech industry, in automotive, or in process industries like life sciences, this is a very, very simplistic picture. But even in this simple picture, and what I just mentioned, in our opinion, it is super important to build a digital representation of not only your supply chain, right? So not only your own suppliers, not only your factories, but also your supplier's supply chain. And I'll talk quite a bit about why that is important and how that brings us back to the factory floor here in the center. So let's just take a look at what are some of the major disruptions that are happening out there. And many of you have read the headlines. I mean, there are always big news that make it into the limelight, like a ship stuck in a Suez Canal. I think all of you read about that incident where basically an entire container ship was unable to deliver, which caused a ripple effect because the Suez Canal was blocked for multiple days, which caused many, many dozens and hundreds of container vessels stuck, which equally had stock on board that couldn't get delivered to their destination. But that's one simple example right here. It's the late ship. Let's talk about the semiconductor shortage. That has its own ripple effects because not only are our end products like my long-due iPhone is delayed, but also components that are used all over the world, including automotive and high-tech industries. So we have material shortages. And the factory that you see here on the top is usually really the, let's say, what suffers from these disruptions downstream, right? In other words, if you have supply shortages, if you have logistical problems, the factory floor cannot produce. At the same time, the factory struggles with its own disruptions, meaning a failure of a production line, shortage of labor, looking at the pandemic. How many factories suffered from shortage of labor and still till they do? I mean, even if I'm sure some of you came here via airport. I did that just last week and it was a horrible experience because there is just no labor anymore to staff the ground staff. So the factory is affected by both sides. It has its own challenges, own disruptions, and it is a downstream impact by supply chain disruptions. Now, what does that all have to do with network or network-aware factories? So our, let's say, strategy at SAP that we work on with many, many industrial companies out there is to use business networks. So not only integrating, like it has been done for the last 40, 50 years, peer-to-peer with my direct suppliers, but really building a business network, almost like a Facebook or LinkedIn, of supply chains. And this is already a reality in logistics. This has been happening for the last 10 years with companies like P44, Descartes, and SAP has basically the ambition to be a network of networks, to build really an ecosystem in the logistics industry, but especially in, let's say, within supply networks, to, very importantly, making disruptions visible. Yeah? So this is really only the very first step, that you, as a manufacturer within the factory, get visibility before your production stands still. And this can only be achieved if you have this multi-tier or really this let's say, multi-echelon, as we call it, supply chain visibility. So an echelon, a tier, like I mentioned earlier, you don't only see what happens to your supplier, but what happens to your supplier's supplier. That is what gives you early enough visibility to react. So that's step one. Step two, and Ewa talked a lot about artificial intelligence. I'll talk about this in a different context here. Step two is making the impact visible to you, right? Just because I know I have stock in a container ship stuck in the Suez Canal, how do I know what customer orders are impacted, what factories are impacted, where is that going to hit me? And that is exactly the second point, to make the impact to a company very, very clear. And this is where intelligence starts. Because obviously without having a digital twin of your supply chain and without being able to resolve complex relationships between raw material, your production, and customer orders that are affected, you will not be able to make these connections, to make that visible. Step three, to then really go into resolution. And quite frankly, this is by far the hardest part. Where in most projects that I've experienced, the maturity of a lot of industrial leaders out there stop here. Or it happens extremely manually, extremely labor intensive, in spreadsheets, and with a ton of phone calls and emails. So what is our vision? It is to have a programmatic approach aided by AI to really simulate alternatives. How do I now resolve my stuck container ship? And there is a plethora of options. I can tell my customer I won't make it. That's the simplest option, but probably the least liked by you and your customers, affecting your top line and profitability. You can reprioritize. You can say, I know I will not be able to make your customer order, but I can still make another customer's order. So I'm reprioritizing in my production. I can completely reschedule my production, right, and try and find efficiencies within my factory. I can try and outsource it, right, give it to a contract manufacturer. I can see if I can find the stock somewhere else, right? So maybe my raw material is stuck in the container ship, but perhaps somewhere in a warehouse I have that same raw material that I can bring to my production line. Last but not the least, you can try alternative transportation routes. So instead of going via, let's say, like in our example here, via container ship, I can air freight or I can truck my raw materials. So simulation, what-if analysis, but the key is then to really find what is the best and most intelligent action behind this. And again, the way how we resolve this is by combining this digital twin of your network, right? So being network aware as a company beyond your own, let's say, ecosystem, with what we call synchronized planning, which synchronizes your planning processes like production planning, like demand planning, with the reality of your shop floor or of transportation. So in my example here, what are we going to do? Intelligent action. We could choose to perhaps only partially fulfill a customer order. So we're still sticking to our service level, but only partially. On the very left, we actually purchase new material, right? Because the one we want is stuck, right? We purchase new material from our supplier. We airship it, so we accelerate it. We restock the warehouse. We do a replanning of production, so we shift production priorities, and we are still able to at least partially deliver on time for one customer, the other in full. So that is one very, very, very simplistic example of how networks impact factories. But let's make this one level more tangible. So we have also prepared a 3-minute demo of how can this actually in reality look like for a company. So if we can switch to our screen, please. Going from left to right, or yeah, let's start right here. So this is a vision demo out of an SAP ecosystem. And where it all starts is, keep in mind, I went through 4 steps. One was create visibility. So here we see, again, a very simple supply chain. We see actually, I'm in the perspective here actually of a medical component manufacturer, so I'm producing an ingredient. This could also be a chemicals company or a consumer products company. And what we see already here on this map immediately, visually, something is wrong. My ship, in this case, is stuck in Bangkok in a port congestion. And I can immediately see on the right what are my affected products. Even with a little risk score, and this is actually a quite new area for us, where in fact we are partnering with the Technical University of Munich, is risk and reliability-based planning, right? So we are basically enriching this model here of our supply chain, this digital twin as I called it, with how high is the risk of this container not making it. Yeah? Usually planning models are very, very deterministic. They are based predominantly on statistical and historical values. Here we are enriching it with actually a risk prediction. And we see here that my product, Arctic Breeze, let's just say that's a concentrate, right, a liquid concentrate that I want to deliver, is highest affected. So other than this visualization, now let's go to step 2 and look at what is my impact assessment, my impact analysis, like I showed earlier. What are my customers and my orders and my products that are mostly affected? And here, already on the top, we see a certain risk score. We see also the revenue at risk. And what I mentioned about synchronizing this supply chain disruption with planning is what we see right here, right? We enrich this twin of a network with financial data, right? What is the value of my customer orders? Otherwise, I wouldn't be able to predict my revenue at risk. But then most importantly, I enrich it with my, let's say, customer orders and also my situation of stock in my network. And I can see here in my different scenarios, what are the final products mostly affected and my top customers that are jeopardized. So I have now a better impact assessment. Most exciting now, let's go to step 3. And look at what are the resolution scenarios, like we talked about. And similar, like on my slide before, in this example, we have a proposal for 3 potential resolutions to this supply chain disruption. Number 1, and I'll point out especially here also the sustainability impact of doing this. Going from left to right, I could basically put my container on a train from Bangkok, get it to Mumbai, put it on another container vessel, and then get it to my factory where I want to produce my concentrate in Germany. What we see immediately is that the sustainability footprint would be much, much more poor because of the, let's say, supply chain and fuel impacts that this causes. But I see my profit would be higher, but I can, in this case, resolve my disruption, right? So I'm choosing an alternative transportation route. Center option, which the system recommends to me, has a much, much better sustainability footprint. And it is a, let's say, much more radical option. It is, I'm completely shifting my production, right? So instead of getting my raw material that is stuck in Bangkok, I'm actually choosing to produce locally in Hamburg in a factory where I have the same raw material already on stock, which I did not plan to use for these orders, where of course I then have a ripple effect where I need to re-optimize my supply chain plan, my production plan. And very essential, I can only do that and achieve this if I have the full visibility into my factory, into my capacities on the shop floor, into my labor availability, shift plans, and available, let's say, production capacity, right? So what we see here on the bottom, simulated and simplified, of course, is that I have the full visibility that, yes, indeed, I not only can change my logistical route, I can change my production priorities and resolve my disruption with that path. That's what we're going to choose. So we implement now the second option. And last, to close out the demo, we then, of course, also can bring this into the, let me call it, into the shop floor. So where what I just presented happened a lot on a macro level and in the, let's say, visibility between network, supply chain planning, and synchronizing this. Here we are now in the MES, manufacturing execution system, where I can now release and dispatch my replanned order to my production line and produce my Arctic freeze material. Good. In order to close us out, this was really just to make it a bit more tangible. If we could switch one more to the slides and add my closing slide, please. I just want to wrap up with to bring this all into context, thank you, on my last slide. How does this now all fit together? Yeah? And many of you, if I look here on the, let me say, ISA 95-like pyramid, will be working on levels 0, 1, and 2. Right? So this is the reality in factories. This is machines, robotics, and sensors. And our vision or our belief at SAP is that in order to resolve these challenges of modern supply chains, you need to connect vertically from the network, business networks, level 5, where we just got a lot of this intel from that we then used, with the enterprise, with your traditional ERP systems, all the examples I gave, finding out the business impact, what customer orders are affected, reprioritizing your production, and then into what we call the digital manufacturing layer, so into the factories, into the shop floor. And only if we manage to create this, what we believe, close linkage, this integration, this what we call synchronization of material flow in the factory with disruptions of the network, can we equip companies to really resolve those disruptions. Thank you very much. Here is a little outlook of our vision. What I just described, we believe that the future is of making enterprise intelligent lies in this digital twin of supply chains, of networks. And of course, we gave one example only today about the sustainability impacts this has, but I have many customer discussions where we also talk about how can this help, starting from the German Lieferkettengesetz, and building traceability and visibility across supply chains to really tracking CO2 emissions and footprints across echelons of the supply chain. Thank you very much.
So, thank you very much, Dominik. We have certainly some questions. Are there any questions from the audience? Yeah, please.
Thank you, it was quite interesting. So this almost requires a complete integration and complete information data, right? So what happens if some parts of it is missing actually? Or what happens until then?
Yeah, good point. I mean, in our experience, what I showed today is really, let me say, the final vision, but the reality is in many companies, information is missing nowadays. Because either you don't have that full visibility in your network, or you have a patchwork of systems and applications and departments that resolve siloed problems, right? I have only my view on my factory, I have only my view on my warehouse and stock situation. The answer very often lies, sadly, then in manual workarounds, right? So what we can't solve programmatically, you can still solve with teams, right? So I see customers that have entire control tower teams that do what I showed here programmatically in a much more manual approach. So it can still be achieved, but it's certainly much more labor intensive and probably less accurate. So what our approach here is to do this in a much more system guided and automated fashion.
So, oh, please, go ahead.
Yeah, thanks for sharing your vision. My question is, how happy are companies to share such, I would say, the data to contribute to the network? Are they willing to? For sure they get something back, but they open up all their stocks, maybe to a network they don't know who's contributing.
No, that's an excellent question. I would say for me there are two different scenarios, let's say. One is uncritical data. When it comes to logistics, a lot of companies I see have no problem sharing logistical information of I want to move a container from A to B and tender it out to a community of logistics service provider. That's already reality for most global shippers. So there's uncritical business data, easy. Where it gets critical is I have lots of conversations in the context of Catena X, which has actually been incubated here in Munich, not far from here, with BMW, ZF, SAP, many industrial leaders. And Catena X is an industry network, what I described today, specialized on the automotive industry, and they want to share quality data, right? So they want to share with each other fault, or if there was a component failure in my vehicle, being able to trace that back all the way to the tier N raw material supplier. And that's where it gets tricky. The way how we address it is predominantly by bringing the industry together, like in Catena X, because this is an industry, not a technology problem. But then secondly, to do it really business, let me call it, business scenario driven. In other words, I don't just share data, I share it if there's an incident, right? So I do share it, and this is where technology can help, of implementing concepts like data sovereignty, entitlement management, right? So am I entitled to see your data? Are you willing to share it with me? That can be programmatically resolved, but it always needs to be business case driven, right? So if there is a failure in my vehicle, only then will I share with you the component data of that serialized part, but not of my entire production or my entire product range. So those are two aspects, but certainly a problem that is not yet solved, where the industry is really investing in together, like in Catena X in the automotive industry.
I asked myself because at Automatica also, in our group, we are looking into rescheduling production. So, you are rescheduling logistics, and probably when you talked about this vertical integration, I thought actually you would need a solution which also tells you, you will use those robots and those machines, and how I would shift the production within the factory down to the robot level. Are you looking into that, or what's your strategy? Are you partnering with companies for that, or is your vision to go down to that level?
Yeah, to an extent, yes. So this, what I call synchronization that I showed, for us ends on what I would call assignment of production orders or operations to concrete work centers. So that's as detailed as we go. But when it goes even below operation, or then triggering the real let me say, automation layer, that's where we partner with the likes of Bosch, of Siemens, of KUKA, based on industry standards like OPC, or also the asset administration shell, to then facilitate, let's say, the real automation layer that many of you are working in. But at least to the level of operation, that's where we have our finite production plan.
Thank you. Let's thank again Dominic. Now we have a talk from the CTO at Huawei Technologies, Dr. Wang Tong. Unfortunately, he did not manage to come from China. It has been told me. So he also did not manage to have a stable connection. So I think he recorded the presentation, and we will replay that. No questions, obviously. So is this correct, Isabel? How is it? How are we going to handle that? Yeah, I guess you will just start the presentation. It runs for about 14, 15 minutes, and then we come to the final presentation. Okay? So the title is...
Hello, everyone.
Yeah, please go ahead.
Very pleased to have this opportunity to talk about 6G and the future robot. Thank you, Sammy, for the invitation. The motivation for the theme of my talk is the future of the workforce. The workforce we meant here are the skilled and the manual jobs. In the next decade, the shortage of the workforce in the developed country is inevitable. We would end up with 65% workforce availability. This situation is not only for Europe, United States, but also for many other regions. For example, Japan as a result of an aging society, China as a result of a one-child policy. In the near future, the post-lockdown labor crisis is another added factor to this situation. In fact, the lack of a skilled worker is another syndrome of a post-lockdown economy. The second motivation of my talk is the disruptive innovation on 6G. Let me give you a brief picture about 6G. In the 6G world, the physical world and the digital world will truly combine together. For the digital world, 6G is the sensing network of the physical world. 6G is also the neural system for the digital world to apply actions to the physical world. In our vision, in this sense, 6G is a new continuum between the physical world and the digital world. It is a new metaverse of intelligence. The mission for 6G is to create connected intelligence. What we envision in this talk is that in the next decade, we see a massive paradigm shift with the emergence of massive intelligent robots, which means the era for the single-purpose dedicated robots is over. Today, single-purpose robots can do limited tasks. The vision of the new world is an AI brain operating on a general-purpose robot, or even a humanoid robot. This is done by building the human mind cognition structure into a general-purpose robot. With this concept, we train the AI brain in a way that human operating on the general-purpose robot at the initial stage. This is so-called human supervised learning. As AI brain evolves to a certain level of intelligence, the robot can take over the task, do the job automatically. This is not only for a scenario for some of the specified business. Our ambition is that it will also for consumer market. Robot is your personal butler. We're talking about a mass market size of 10 billion affordable robots. How to build a general-purpose robot? In fact, the general-purpose robot is a dumb robot. However, it has an AI brain. In the other word, it is lean on the robot side while it is heavy on the AI side. At the generous time, the robot has little intelligence. The human workers start to teach the robot to do the real-world tasks. The human operation is treated as a ground truth for the deep learning neural network to learn. Now, the AI robot can learn 24/7 at anywhere on the planet as long as they have 6G connectivity. More specifically, the 6G eMBB is used for virtual reality, and 6G URLC is used for transmission the command to perform the physical action. The AI brain can be more dynamic with orchestration. Here, we actually operate the robot to teach to construct the AI brain to further explore the orchestration of mini tasks. To make robots smart, the AI brain plus the human labeled learning has three different phases. The first phase is active AI experimental learning, that is the supervised learning. The second phase is the synthetic reflection or observation, that is to perform experiments on the digital twin. The third phase is abstraction of conceptualization of machine learning, that is the action on orchestration and choreography. Single platform and single robot. In this way, the robot is just like an iPhone and truly universal. The intelligence of a robot is enabled through the cloud platform, and the AI enabled through the cloud platform. All the human tasks can perform on this platform. This platform can imitate human brain dynamically and orchestrate the visual, sound, touch, motion, and task planning. Even more, it can evolve into full autonomy as it learns the task to learn through the experience like human. The AI brain platform can also enable all robots to learn from each other. In this case, robot is an iPhone. We create an elastic on-demand workforce. This also enables scalability of the workers, so that one person can do the work of many persons. Essentially, the worker becomes the supervisors, and the robots becomes the autonomous workforce. When you need one, you can call them in. If you don't need the one, you can share with someone else. Let's consider the robot as an iPhone, then the AI platform is an equivalent iPhone ecosystem. The robot contains a so-called operating system which runs the app. For example, the app to program the cloud, to command the robot to do the work at home and the factory remotely. The key ingredient is 6G. Here is 6G is like the operating system for iPhone. I would like to elaborate further. For 6G, in addition to transmit bits, we can receive and detect the radio waveform with advanced signal processing techniques. We can detect the object signal parameter values such as a location, velocity, and the moving trajectory. We can also reconstruct the object imaging for the real-time environmental learning and build into AI service and inferencing learning service. Furthermore, we can analyze the spectrogram of objects. Sensing will be a perfect complementary for 6G to enable general-purpose robot. Use 6G sensing as a general-purpose sensor to unify all the sensors used for the single-purpose robot as we do today. In addition, sensing is the source of massive data for machine learning. It is automatically built in with the same chip, same frequency spectrum, same air interface with a global unified standard. The 6G ASIC, integrated sensing and communication, can be very powerful when using the sub-terahertz spectrum or terahertz spectrum to perform radio sensing. A great potential to achieve ultra-high precision sensing while reaching the millimeter level of accuracy. By combining with the powerful signal processing techniques and the 6G ASIC can see the object and can perceive the shape of the object and can analyze the material of the objects. Here we listed some of our physical limits of a 6G ASIC defined by Arby, Fraunhofer, and Rayleigh. With the advanced signal processing technique, 6G ASIC can approach these limits. To make the general-purpose robot feasible, one of the key technical challenges is to use 6G ASIC as a terahertz camera. To use a terahertz camera to replace all specialized sensors to fulfill the same task that a single-purpose robot can do. We, as a human being, to perform a job, we use all our sensors. Today, there are many typical sensors are used for robots. For example, contact sensors, tilt sensors, acceleration sensors, proximity sensors, distance sensors, cryoscope sensors, navigation sensors, position sensors. Our goal is to use 6G terahertz camera to replace all these sensors, to use the deep neural network for the behavioral learning and modeling, to make 6G ASIC as a universal sensing platform. With 6G ASIC technology, a universal global technology, we can make a universal, affordable consumer robot to create a mass market. Their potential of applications is limitless. For example, hospitality service, cook a feast, housekeeping, remote health service, assist the living of the elderly, logistic, become a repairman, physical service, construction job. The key proposition is to use 6G platform for consumer robot platform. The consumer robot is simply a 6G device like iPhone. On the 6G platform, we built robot ecosystem. The expertise for each business will transfer their domain-specific knowledge and know-how to become a 6G app. The creation of a 6G robot app is where the expertise can make their business and profit. Again, each specific task we need to go through the workflow to create 6G app on the 6G platform. Like step 1 is human as a robot to teach. Step 2, robot assist and augment. Step 3, robot becomes semi-autonomous. Step 4, human complete skill transfer. Step 5, robot works automatically. Let me finish my talk by showing a toy example for the 6G ASIC-based general purpose robot. This is a classical scenario for two single-purpose robots to collaborate to finish a job. They are programmed to do the job step by step. Here, the action at each step is called a mini task. The sequence of the actions from step 1, 2, 3 we call the orchestration or the choreography. Our goal is to model the mini task and the orchestration by machine learning on the 6G platform. Now we use 6G ASIC and specifically the 6G terahertz camera. We can perform the same task by interleaving the sensing and communication in the process between the robot actions for the mini task and the orchestration as well. To use the machine learning to learn, to analyze, to inference the actions for each robot, and to use 6G URLC connectivity to command the robot to perform the job. To wrap up, the takeaway message is the 6G consumer robot as an iPhone. The market potential is huge. For example, it is $930 billion per year market for senior people crisis, in which the health and Medicare is about 26% CAGR growth. And why 6G? 6G is a global platform for connectivity and computing and sensing. 6G can deliver AI service anywhere, anytime. 6G is a continuum between the physical world and the digital world. 6G connectivity enables the perpetual learning and the universal inferencing service to all robots. On 6G platform, robot will bring the service to you. You can order any robot you want. The instant service at home, office, clean, cooking with a single universal robot. Instant doctor, instant nurse offers the service with no time. Robot Butler become a family and friends physically. And it evolves to next iPhone as a personal assistant and provide all the daily needs you want. And finally, robot will become your butler. With that, I conclude my talk. Thank you very much.
Yeah. So, really visionary and inspiring talk. We would have had a lot of questions, I guess. But I don't know, is Jürgen Grottepass here? He is the Huawei person in Munich, and he's been also part of the Roboton jury. Unfortunately not, because he could have answered also some of those questions. Anyway, I think he will be around on the fair from what he told me. Okay, but then this brings us to actually the last talk, and I'm very happy to welcome Dr. Anna Bauer-Mehren. We know each other from the Bavarian AI Council, where we are trying to push forward artificial intelligence on a wide basis here in Bavaria. She is head of data science at Roche Innovation Center, and she will completely switch the topic. It will be about AI in pharma R&D. I know your work. It's very exciting, so let's welcome Anna Bauer-Mehren.
Thank you.
Welcome.
Perfect. Yeah, so actually I would love one of those robots, right, if they already existed. I mean, that was super exciting. Unfortunately, not here yet, right? Yeah, as you said, right, we will switch gears totally. I feel a little bit like a stranger here because my background is really life science, so I have a PhD in bioinformatics. So we are really now going to a very different topic, but I hope it's still exciting because unfortunately, I'm the one preventing you to get food, and I'm already starving. I don't know about you, but it won't take that long. So yeah, it's my pleasure to talk about AI and pharma R&D. So we will really now go to the early phases of where we look into research and how we actually develop drugs. And one of the big challenges when you work actually on developing drugs is that every person is so special and so different that we basically don't understand much. And that's also the reason why most of our drugs, or most of the drugs that are being developed, fail. I'm not sure if you're aware, but the failure rate is 90%. So basically, almost every project you will work on when you work in pharma R&D is gonna fail. And that's sometimes quite frustrating. On the other hand, it's also quite exciting if you're part of a project where the drug really goes to the market and is really helping patients in need. And this is really, of course, our vision also at Roche. We want to develop medicine, novel therapeutics, where really each patient benefits. So meaning the drug is working, it has the desired effect, and ideally there's no adverse events, no side effects, right? Why is this especially exciting in times of digitalization? So the reason is we can nowadays really gather much more data, not only about the disease and what's going on, let's say in a tumor, but also about the patient. So you see here some of the digital tools. We can, for example, look into electronic patient records, understand a little bit more about the medical history of patients, what's the vaccination pattern, what's the sleep behavior. Many people have these fitness watches where you can actually track your sleep behavior, for example. You can track your blood pressure and other things. And then we see here there's huge advances in several technologies. So today we can really sequence the whole genome. We can really get more insights into the biology, into the genes that we all have. And the last one is imaging technology. We can get much more detailed information using imaging. For example, this is a tumor biopsy, what you can see here, where we can really look into the tumor microenvironment and really look which cells are actually there and which cells are involved at the moment. So now we heard that, I think Ewa and others also brought it up, right? Data is important. Data is extremely important, and also for us. And these data can come, of course, either from clinical studies that we can do as a pharma company, but most of the data actually sit in what we call real world, in the real world. So they're actually produced when patients go to the doctors, they get diagnosed, they get certain medications, and these data is what we call real world data, and you can see here some of the examples. So these are, for example, data from these electronic patient records. These can be imaging data when you go to radiology or something like that. These can come from these sensor technologies. So we talk about digital biomarkers in this case. from your fitness watch, from your iPhone, from other things. It can also be social media data, actually a data source that we are using more and more because patients talk there quite openly about symptoms and what is bothering them. And we are using that to make our drugs also better drugs in the end. And why am I talking about that? Well, the reason is, and this is here quite nicely illustrated, is the majority of these data is really not in our hands, not in the hands of people who want to make these better drugs, but really sit out there in the real world. So you can see here an example from oncology. 95% of the data is in the real world. Only 5% is owned or generated by not only Roche, but all the pharma industry, including university that are conducting clinical trials. So really, really small portion of the data. And all of you who do AI know if you really want to do AI and understand something, you only have access to 5% of the data. Not ideal, let's say. I want to talk a little bit about the pandemic because it's still kind of in all of our mind, right? And I think this term real-world data is now more known by everybody because it played such an important role during the pandemic. So these kind of data, these real-world data, were really used by policymakers to take better decisions. They were used to study, for example, efficacy, adverse events of the vaccines when they were already approved through this emergency approval mechanism that got in place. And it really emphasized how valuable these data are to take the right decisions at the right time. And this is also what we want to do, or what we are actually already doing for quite some time, in particular in oncology. So we are really trying to use these so-called real-world data much more to develop these better medicines. And here's just from the Roche family, a company called Flatiron, who specialized in making these oncology patients' records electronic, so to digitize them, bring them into an electronic format so that it can be really analyzed by people like me. And then on the other hand, Foundation Medicine, this is a molecular genomics company who specializes on understanding the profile of a tumor. And then when you bring these data together, what you can do is you can really learn from these data and understand why certain patients, for example, respond to therapy, why other patients do not respond. And more importantly, you can also, when there's actually, you have tried everything, you went through all your standard therapies, chemotherapy, and so on, radiation, whatever it is, and figure out you may have certain mutations that actually would warrant you to get a more targeted therapy. And that's also what is being done here for clinical decision making, really impacting patients' lives. Yeah, so let's now go to AI. I talked a lot about data. Of course, we want to also talk about AI. Here you see the classical pharma R&D chain. So what we have to do, and I'm not sure how much of you are familiar, we'll go rather quickly over this, but first you need to know what is the target in the body that you want to actually put your drug towards, right? Is it a protein? Is it a gene mutation? What is it actually that is kind of druggable so that you can somewhat cure or at least minimize the symptoms of a certain disease. And ideally you want to cure, but it's not that easy usually. Then you, of course, have to find a molecule that can drug this certain target. That can be a chemical compound, it can be a large molecule, so that's a protein, whatever it is. But this development is also hugely intensive, and here also many of the projects fail. And then at some point, you really go into the patients. That's then the last step, the clinical development, where you go through multiple phases in the clinical development to see is your drug actually safe and does it really work. And in all of these areas, and this is just really a fraction of examples, we use AI. And we have always been using AI for quite some long time, actually. Main problem for us is really getting access to these data, and that's why this digitalization is so exciting for us, because we can actually now leverage more data to do better things. Maybe a few things I want to mention, because it was mentioned by Ewa earlier. In some of these examples, or in some of these cases, it's also about automating this process, because if you are developing a molecule, you're actually always doing the same steps. So some of these AI use cases is a little bit maybe more familiar to what you do. You want to automate that, right? You want to operationalize it. So we also actually work on the same concept, operationalization of AI, because we need it for some of our use cases. And then we have other use cases where you really don't care, because the only thing you care is the features that you extract, which tell you something about the disease biology, and then you just use this information to make a better drug. So we really have these two types of use cases, some that we want to operationalize and others where it's only about the science mostly, and then we can actually throw them in the bin and not care about the model itself anymore. And another one I just want to highlight because it came up, we also talk about digital twins, but in our context, this is something very different. So what we want to actually build here is a digital twin of the patients in our trial so that we can try out what would happen if I gave a different therapy, a combination therapy. I left out certain things, what would happen? And I can tell you this is not trivial at all because basically no one understands human biology really. So it's quite exciting, but also frustrating, as I mentioned. So now I just have a few use cases. I hope it's somewhat interesting to you. Some are related to the recent pandemic. So this is a use case where we indeed use these electronic health record data. And luckily, because the pandemic was such a dramatic event for everybody in the world, these data got accessible quite quickly. So there was quite nice to see how quickly one could get access to electronic health record data of patients suffering from COVID-19. And interestingly, all these data usually come from the US, maybe some other European countries, certainly never from Germany. So this is really something where Germany is always last, maybe next to Austria. But not so great. But the US, we had these 120,000 patients, and then you can apply some machine learning, you can apply some more general statistical models, whatever it is. Not too important which model it is. What we are more interested in, what are the features? So that's exactly what I meant. We wanted to learn what are actually features that could tell us something about the risk to die. Because this is still up to today very unclear. Why do certain people react so dramatically, and why do others actually have just a little cold and don't feel much, right? It's really still not totally understood. And this is just our work contributing to the huge work everybody in the world did on this topic. And what we basically found is that an electrolyte imbalance may also be associated with this higher risk to die. And that is actually something that clinically you can manage quite easily. So that was a nice paper for those of you who want to read more. And what we're doing now, which is even more interesting, I think, is we're now looking into similar data sources to understand something about long COVID. Why are certain people developing these long COVID and others are not? Can we do something about it? Can we maybe make a drug for them so that we can reverse what's happening there to the immune system? Another example is now from oncology. It's also quite interesting, again, because we don't really understand disease, we don't understand biology, unfortunately. What we see is that many patients, even though they're prime candidates for receiving a cancer immunotherapy, where you actually want to boost your immune system to tackle the cancer again on its own, which is the immune system's task to do, but in cancer, somehow the cancer makes the immune system not see it, or it escapes the immune system constantly, so the immune system cannot do the job it's supposed to do. And these therapies that we are developing are trying to boost the immune system to actually go back and tackle the tumor. Unfortunately, even though you're a prime candidate for these therapies, many of these patients, you see it here, I think 30 to 40%, develop what we call a resistance. So somehow over the treatment course, suddenly doesn't work anymore. And now this combination of how are these patients treated, what is the genomic profile of the tumor, becomes very valuable, because now we can actually look into these data and try to figure out what are the patterns, why certain patients develop these resistance. That's exactly what we do. And then, of course, what do we do with these data? We find these new targets, and then we start developing a new medicine that's hopefully going beyond these resistances. Yeah, now another example from oncology, also quite exciting. This is about prognostic scores, and that is in particular important when you develop a drug. You want to know what's the prognosis of your patients. And unfortunately, the patients we are mostly looking into are patients who had been through several lines of therapy. So they start with a standard of care, they do another line, they do another line, they do another line. Nothing seems to work. And these are typically the patients that then enter a phase 1 clinical trial in oncology. So typically these patients have only very few weeks to live. And that is, that is something that we really need to understand, because on the one hand, it's unethical to enroll a patient who has very few weeks to live, because going into a clinical trial is a lot of stress. You have to go, you have to give samples, so blood sample, maybe have to get a biopsy of your tumor. So it is a lot of stress, right? So you don't want to bring patients in that have only these very few weeks to live. And on the other hand, it's very important information for us as well, because we only recruit very few patients into these trials. And if basically the majority of them dies in the first few weeks, there's a zero chance we can understand anything about the molecule. And that's then not only bad for us as a company, but it's also bad for all the other patients, because such a trial would typically be stopped because you cannot prove efficacy, and then potentially a good molecule is not given to patients in need. And that's why we developed this score. So here again, we used electronic health record patient data. Actually, we started off with more than 2 million patients. We had to drill down then to 125,000 roughly because of data quality, longitudinality, missing data, whatever it is. And here we also learned quite a bit about different types of AI models. I think Ewa talked also about black box. This is for us huge, because if you want to bring such a model through the regulatory authorities in healthcare, this topic about we don't understand what's going on is extremely important, right? And in this example, interestingly, the very easy model, the one that is not a deep learning model, is actually similar performing, which means we will just use the simple model because it's just easier to explain. In a nutshell, it's a model that consists now of 27 parameters, which are combined, outperforming all other prognostic scores that we know today in oncology, and it is now being used in phase 1 for patient recruitment, actually. Another use case that we have, and that's, I think, my last one, is the same model can actually be used because you can monitor patients over time to really understand early on, will this patient benefit from therapy or not? And again, this has now 2 application areas, one for us in development, where you can then early on decide this patient is not responding, the molecule is likely not doing what it's supposed to do, so we can stop a trial earlier on. And also in the clinical practice, it's important because physicians may decide to switch therapy if they actually see this score behaving in a, let's say, not wanted or not desired way. Yeah, so we don't have to go through this, but I think what I want to emphasize is access to data is for us hugely important. Real-world data plays an important role because it's the majority of data of patients, and yeah, digitalization is really for us super exciting. But unless these digital twins of factories where I think the behavior is rather clear and you can do a lot, I think in biology and medicine we are really at the beginning because we don't understand much. That's it. Thank you.
Thank you very much, Anna. Questions? So I wondered, I mean, these PD-1 drugs, right, in some sense, they are very innovative. I think it was a Nobel Prize in 2018 or something like that in medicine, right? Because it was discovered that the immune system actually can fight cancer, and the drugs just to support the immune system. And now you highlighted this analysis. So how far? What's the current stage at Roche in developing and going even one step further? And is the prognosis that actually this kind of therapy will take over and completely replace chemotherapy, or?
Yeah, I think there's still a lot of research ongoing in cancer immunotherapy, so it's still really part of the future, I would say. Yeah. I think what is now more and more coming is this combination therapy, because we talked about resistance, right? And what you see is that, yeah, even if you boost the immune system, the tumor finds mechanisms to again escape this. So then you actually have to come from a different angle to the immune system. And maybe what I want to mention also, this long COVID is very much related to a disruptive immune system. So there is also the synergies that we're trying to find to, in the end, better understand the immune system itself, right? And this, I would say, is in really early, still in very early phase.
So your data analysis tools which you are applying, are they in this clinical trial procedure, or are you a step before that? Where is your research placed in this chain?
No, we support all, basically from target to phase 1, and that means that these very early phases. Later, when it goes in later clinical development, then it's other groups. But we do the whole research from target to the clinic.
Okay. Thank you. As you said, probably you are waiting for lunch, all the others are waiting for lunch. Thank you very much, Anna. I would like to close this session. This was a bit of out-of-the-box session, especially for the automation robotics people. We took a very high perspective and looked into different innovative industrial areas. After lunch, we will have Professor Krupasik looking into automation, and the session is called Industrial Perception and Autonomy. So enjoy lunch. We still have about 55 minutes, I think, time for lunch, and then let's meet again here 1:30. Thank you.